Hello everybody, so welcome back to my channel AKB Tutorials. So in this channel we are discussing various topics related to mechanical engineering. So today we will continue the last topic, that is one of the most important topic is Mohr Circle. So in last video we have seen how to draw Mohr Circle. So Mohr Circle is very much useful for two-dimensional stresses. So to find the stresses on an inclined plane accurately as well as rapidly, so we can use the Mohr Circle. So the Mohr Circle allows us for rapid and accurate calculation of the various parameters. So I am writing one by one. That is, first one, the maximum and minimum principal stress. So we have studied the principal stresses. Now by using Mohr Circle we can find the maximum and minimum principal stresses which can develop because of that complex stress system. Second point, we can find the maximum shear stress which can develop because of the stress system acting on the body. Next, the angle of orientation of the principal plane elements and maximum shear elements. Next, we can find the normal stresses that exist along with the maximum shear stress element. And at last, that is the stress condition at an angular position. So all these things we can find by using Mohr Circle. That's why Mohr Circle is that much important. Now the first point we can find, that is the maximum and minimum principal stress. The maximum and minimum principal stress and minimum principal stress. So the maximum and minimum principal stress which is developed because of the complex stress system. So consider an element or the body is under the complex stress system. Let sigma x is acting along x direction. So we are considering positive. Sigma y is acting along y direction. That is also positive. That is tensile stresses, as well as say on x face shear stress is acting in anti-clockwise direction, that is tau xy. So complementary shear stress will develop on y face, that is tau xy. Now we have to find for this what is the maximum and minimum principal stress developed in that body. Now for this, first draw the Mohr Circle. So to draw the Mohr Circle, so we have got the idea how to draw the Mohr Circle. Draw two axes, that is sigma axis and tau axis. Okay. Now first plot that x face point, the stresses acting on x face. So for time being, consider that this is 100, sigma x is 100 megapascal and sigma y is say 60 megapascal and tau is 40 megapascal. So we are considering this. Okay. So now the x face point, that is stresses acting on x face, 100 megapascal tensile, that is positive, and 40 megapascal in anti-clockwise sense, that is also positive. So by using a scale, say this one indicates 100 megapascal and 40 megapascal. So in positive side, say this one is 40 megapascal. So we will get the first point, that is 100, 40. Now go to y phase. See the stress condition. Here sigma y tau xy. What is sigma y value? 60 megapascal and tau will be 40 megapascal. So 60, 40. So similarly, by using the same scale, you mark here from origin, move 40, then sigma y is positive, tau xy is in clockwise sense, that is negative. So minus 40. So 60 minus 40. So let this see the point marked by the scale, that is 0.2 and that is 60, 40. Now join these 2 points, 0.1 and 0.2. It will intersect somewhere on sigma axis. So that will be the center of Mohr circle. I am marking by point C. C denotes the center of Mohr circle. So by using pencil compass, take this one as center and this distance as radius, complete the circle. So this becomes the Mohr circle. Okay. So we have got the Mohr circle. Now, as per our definition of principal stress, what is principal stress? The normal stress which acts on principal plane is called principal stress. Now what is principal plane? The plane on which shear stress is 0, that is principal plane. So now in this circle, we can see this is the point, one point, and this is the second point where tau value will be 0. So that means this point and this point indicates the principal plane. So this point, so if we mark, say point D and point E, point D and point E indicates the principal plane, and the stress, normal stress corresponding to point D will be the major principal stress, and stress, normal stress corresponding to point E will be the minimum principal stress. So that means measure the distance from 0 to D, or okay, this distance. So measure the distance by using same scale. So that will be your major principal stress, that is denoted by sigma 1. And measure the distance from origin to this point. So this distance will be your sigma 2, that is minor principal stress. And the nature of the stress, that is from origin both the stresses exist on right side. That means both the stresses will be tensile. Okay. So by this way we can find the principal stresses as well as the principal planes. So step 1, draw the axis. Next, step 2, just plot this point, point 1, that is x phase point. Then plot point 2 as per the information here, sigma y tau xy. Point 2, join point 1 and point 2. It will intersect somewhere on sigma axis. So that will be the center of Mohr circle. That means find out the center of Mohr circle. Then measure the distance from D to O. That distance will be your sigma n, sigma 1, and measure the distance from O to E. That will be your sigma 2. So by this way we can find the principal stresses which exists because of the stress system acting on the body. So any problem, you take any problem and solve by this way, following the various steps, so you will get the result. Next we will see the maximum shear stress. So in this case, so you can find, so this is the Mohr circle. For this condition of stresses are shown on the element. Now this is the angle made by this is the x direction. So we have not marked x direction, but x direction. So x direction. Okay. If we rotate the x direction in anti-clockwise sense, so that by this angle, that is 90 minus theta angle. So this is the x direction. X direction makes an angle theta. So now if we rotate x direction in anti-clockwise sense by 90 minus theta degree, this is 90 minus theta, so that this x direction will come here. At that time, this shear stress will be maximum, and the maximum value of shear stress will be equal to the radius of Mohr circle. So that means when this x direction is rotated in anti-clockwise sense by 90 minus theta degree, so this point new x direction will come here, that is the new x direction. So you can see the shear stress. At this point shear stress value is this much. Okay, and exactly at above or below the center of Mohr circle, the stress will be maximum. So this is the maximum shear stress which you can find from this Mohr circle. Now we will see the next point, that is angle of orientation of. So we have seen the maximum and minimum principal stress. Now next we have seen the maximum shear stress. So we will also see from the next diagram what is the maximum shear stress. Now the angle of orientation of the angle of orientation of principal stress element and maximum shear stress element. Maximum shear stress element. Okay. So we are considering a body under stress, say sigma y and sigma x stress is acting over the body. Okay. Now we are going to draw the Mohr circle for this stress condition. So for drawing the Mohr circle, first you draw the axis. Say this is the origin and this is your sigma axis and this is the tau axis. Now plot x phase point. So here it is seen that tau is not there, shear stress is not there in the element, only sigma x is acting. We are considering sigma x is equal to 40 megapascal and sigma y we are taking sigma y we are taking say 80 megapascal. Okay, no problem. Now in this, what is the x phase point? That is 40 megapascal. So by using some scale, you consider say this is 40 megapascal. Tau is 0, sigma x is 40. So we have got the first point, just mark it as 40, 0. Tau is 0. Sigma x is 40. Now go to y phase. What is the stress condition? Only sigma y 80 megapascal is acting on y phase. Tau also 0. So by using the same scale, if this is 40, this becomes 80. So we will get second point, that is point 2, that is 80, 0. So we have got 2 points. Now in this case, so this is point 1, this is point 2. Divide this distance into 2 equal parts. So you will get the center of Mohr circle. Okay. Now by taking this one as center and this one as radius, complete the circle. So this circle becomes Mohr circle. Now the first case we have seen, if we need to find the principal stresses, so this point will indicate principal stress, this point will indicate principal stress. This is the major principal stress and this is the minor principal stress. Here major principal stress becomes 80 megapascal and minor principal stress becomes, that is 40 megapascal. Okay. So that we know. Now we want to mark x axis. Where is x axis? So first point is plotted here. So you can see this is the x axis. X axis. Right? Now if we rotate x axis, second point, the maximum shear stress, if we want to find maximum shear stress. So now rotate this x axis, so we will get maximum shear stress. At this point shear stress is 0. So now if the point exists here, so we can find this is the shear stress, this much will be the shear stress and this will be your sigma n value. Now if the point lies here, so that means this will be the shear stress value and this distance will be the normal stress value. So on the inclined plane, if we rotate x axis up to this, so that this point is just above or below point C, that will give the maximum shear stress. That is the second point what we have discussed. So maximum shear stress will be equal to the radius of Mohr circle. By measuring the radius of Mohr circle, we can find what is the maximum shear stress. So this point indicates tau positive and this point indicates tau negative because it is in the negative direction. Positive negative means this point indicates anti-clockwise stress and this point indicates tau negative means it is a clockwise stress, clockwise shear stress. Okay. So now next we will see the angle of orientation of stresses. So for this, so the condition remains same, only one thing we will do, that is draw the plane. So let this plane makes an angle theta here. To find the angle of orientation, so we have to consider shear stress. Okay, let us take shear stress also. Okay, the shear stress is also acting over the element. Now let this value is 20 megapascal, 20 megapascal. Now draw the Mohr circle for this. So we are studying this, the angle of orientation of principal stress element and maximum shear stress element. So for this, first draw the Mohr circle. So from x face we have got 40, 20. So that means, say by some scale 40 and 20 is positive, 40 is positive, also 20 is positive. So we will mark this point as 1, that is 40, 20. Now go to y face, sigma y 20, sigma y means 80, 20. So by using same scale you mark here, say 80 and 20. We have got this point, that is point number 2, that is 80, 20. So we have got 2 points. Now join point 1 and point 2. So it is as per the construction of Mohr circle. So we will get point C, that is center of Mohr circle. Then taking this one as center and this one as radius, complete the circle. So this is the Mohr circle. So we have got the Mohr circle. Now find the x direction. Where x direction? From center to the point where x face point is plotted. So x face point is plotted at this point. So from center, so this direction will be x direction. Now we want to find the angle of orientation of principal stress element. For this, so we know principal stress we will get at this point and at this point. Now for this we have to rotate this by this much angle. So we have to rotate x direction by, say, this angle, it is 2 theta angle we are considering. Say it is 40, so 2 into 20. So in circle we have to rotate 2 theta so that this x axis will come here. That means we will get the minor principal stress. Okay. So x axis, if we rotate in anticlockwise sense, we will get this minor principal stress plane. And if we rotate x axis by this much angle, that is 180 minus 2 theta, 180 minus 2 theta, then we will get major principal stress plane. So in this body, okay, so I am drawing again the body, only the stresses I am not drawing. Okay, this was the element, let this was the axis. Okay, now we have to rotate x direction in anticlockwise sense by 2 theta, so we will get minor principal plane. So here draw an angle that is equal to theta and draw this parallel line to this, parallel line to this, okay, and draw the perpendicular line here. Okay, so if we rotate by theta angle, so we will get minor principal stress plane. So this will indicate the minor principal stress plane. This plane is the minor principal stress plane where sigma 2 stress will act, and this is the plane which will be at an angle 90 degree to sigma 2 plane, that is the major principal stress that will act. Now again I am coming, so the stress condition is given. Now from this stress condition, first draw the axis, plot point 1 and point 2, find x direction, draw the circle, then find x direction. Clear? Now from this figure, from this circle, it is saying if we rotate x axis by 2 theta angle in anticlockwise sense, we will get minor principal plane. So here this was the axis, so if we rotate this is also x axis, you can see this is also x axis. So if we rotate x axis in theta angle in anticlockwise sense by theta angle, so in anticlockwise sense, so you can see here in anticlockwise sense, so here also it is in anticlockwise sense. So here it is 2 theta angle, but here it will be theta angle, and draw this perpendicular, so this will be your minor principal plane. Okay, and if we draw perpendicular to this, so that means this is the perpendicular, so this plane will be major principal plane. So by this way we can find major and minor principal stress elements. Now we want to find the maximum shear stress element. How to find maximum shear stress element? So we know the maximum shear stress will occur at point just above this point, means above the center or below the center of Mohr circle. So to get that point, we have to rotate this x direction in clockwise sense by 90 minus 2 theta angle. So you can see from here 90 minus 2 theta angle. Then we will get this point. This point and this point indicates the major principal stress plane. Okay, so if we draw the body again, okay, say this is the axis. Now x axis is rotated by 90 minus theta, 2 theta angle, 90 minus 2 theta angle in clockwise sense in the circle. So we will get this point, the point just above the center of Mohr circle. Then here we will rotate this x direction in the same sense, that is in clockwise sense. So here also we are rotating in clockwise sense, and draw two parallel lines to this, parallel lines to this, and then draw the perpendicular here. So if we rotate this one, how much angle? This is 90 minus 2 theta divided by 2 angle. Okay, in circle it is 90 minus 2 theta angle, and in actual body we have to rotate 90 minus 2 theta by 2, that is whatever is coming. So we will get this plane. So this plane will have the maximum shear stress, as well as this plane will have maximum shear stress, which is at an angle 90 degree to this. So this plane will have maximum shear stress. Now you can see, shear stress, we have shown normal stress, shear stress. So this one, you can see this stress is positive, means it is in anti-clockwise sense. So you can mark here anti-clockwise sense, and this stress will be negative, that is in clockwise sense. So we can mark here like this. Okay, So to get the maximum shear stress element, what we are doing in circle, if we rotate this x-axis by 90 minus 2 theta angle in clockwise sense, we will get maximum shear stress plane. So in actual body, so first you draw the axis, then with the axis draw this line which makes an angle 90 minus 2 theta by 2 angle. Okay, draw the parallel line, then the perpendicular lines. So when we rotate this x-axis in clockwise sense by 90 minus 2 theta by 2, we get this plane. So this plane will have this tau, that is positive tau, that is anti-clockwise sense it is acting. And with this plane, the plane which is at 90 degree, that will have clockwise shear stress. So it is shown like this. Okay, this is about the angle of orientation of principal stress element and maximum shear stress element. Now we will see the next one, that is normal stress that exists with maximum shear stress. The normal stress that exists with maximum shear stress. So take one example. Let the body is under, say, sigma x, that is 20 megapascal. Okay, and say sigma y, it is given 40 megapascal. As well as it is also acting shear stress on x face, it is in clockwise sense, say it is 20 megapascal. So on y face it will be in anti-clockwise sense, that is 20 megapascal. Now we have to find the normal stress that exists with maximum shear stress plane. So to find this, draw the Mohr circle. Okay, so draw the axis. This is the origin, sigma axis, and this is tau axis. Okay, now for this, first you take the points, that is 20 is positive and this shear stress is negative. So 20 minus 20. So this is the point we will get. First point, that is 20 comma 20, that is sigma x is positive and tau is negative. Second point, go to y face, that is 40 positive and 20 also positive. So 40 positive, so from here to here it is 40 and 20 the positive. So we got second point, that is 40 20. Okay, so this is the point number 2, this is point number 1. Join point 2 and 1 and draw the Mohr circle. So, you have got the Mohr circle. Now, where is the x direction? So, where x point is plotted? At point 1. So, this is your x direction. Now, what we are going to find? The normal stress that exists with the maximum shear stress. Okay, when we will get the maximum shear stress? Just at above or below the center of Mohr circle. So, if we draw a vertical line through this point C, so this point and this point will give us the maximum shear stress, and the magnitude of maximum shear stress is equal to the center radius of Mohr circle. So, that we know. Now, at this point, what is the normal stress? So, this is the normal stress acting along with the maximum shear stress, that is sigma n. Is it clear? I hope it is clear. Now, we will see we will see some more problems of Mohr circle in the next video. That is the 5th point, the stress condition at any angular orientation. I hope by this time you can draw independently the Mohr circle and find the various parameters what is required. The required parameters, so whether it is maximum principal stress, minimum principal stress, maximum shear stress, angle of orientation of maximum shear stress and minimum shear stress, and the normal stress that will act along with the maximum shear stress plane. So, and one point is left, that is the stress condition at any angular orientation. Because if we change the angle, that is theta, then the stress will change at every inclined plane. So, that is also most important. So, we will see in the next video. Okay friends. So, if this video is helpful to you, please like, share and subscribe the channel. Thank you, and we will meet you soon.